Hello everyone, welcome to Sankalp Learning Solution. I am Vijay Shri. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us look at the first question. According to Hooke's law, if the stress is reduced is 1/3, the ratio of stress to strain is options. Option A is increased to 3 times, option B is decreased, option C is 0, and option D, it remains constant. So according to Hooke's law, the stress is reduced to 1/3. 1/3 of its original value anta kottidare, right? So we need to identify what happens to the ratio of stress to strain. Okay, so four options we are given. So let us write the Hooke's law. What is it? Stress by within elastic limit, stress divided by strain, which is equal to constant. Within elastic limit, stress divided by strain is equal to constant. That constant is called as Y, which is called as Young's modulus. Right. Now, so ಇದನ್ನ ನಾವು ಸಿಂಬಾಲಿಕಲಿ ಬರೆಯೋಣ. ಸ್ಟ್ರೆಸ್ ಅನ್ನು ನಾನು or y equal to ಸ್ಟ್ರೆಸ್ ಅನ್ನ ನಾನು ಈ ರೀತಿ ಸಿಗ್ಮಾ ಅಂತ ತಗೊಳ್ತೀನಿ, ಸ್ಟ್ರೇನ್ ಅನ್ನ ಈ ರೀತಿ ಎಪ್ಸಿಲಾನ್ ಈ ರೀತಿ ಒಂದು ಸಿಂಬಲ್ ಅಲ್ಲಿ ಡಿನೋಟ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, okay, so new stress, this is the Young's modulus. Here Y is Young's modulus. This sigma is stress, and epsilon type symbol which represents the strain. So new stress, according to Hooke's law, stress is reduced to 1/3. So new stress new stress which is equal to 1/3 of its original stress. Therefore new, as we know, new strain ಏನಾಯ್ತು ಆಗಿದ್ರೆ, therefore new strain, as we already know, ಇಲ್ಲಿ okay, strain is directly proportional to stress, right? Strain is directly proportional to stress. Therefore new strain which is equal to this epsilon type symbol by 3, right? So ಇವಾಗ ನಾನು next slide ಗೆ ಹೋಗ್ತೇನೆ. So let us find the new ratio. Okay, new stress divided by new strain, which is equal to sigma by 3 divided by E by 3. So ಏನಾಯ್ತು, cancel 1 by 3, 1 by 3. This will be sigma by epsilon. So sigma by epsilon andre which is Young's modulus, which is constant, which is constant. Therefore conclusion is what? What is the conclusion? Even though both stress and strain become 1/3, the ratio becomes same. Okay, so option D remains constant, which is the correct answer here. Even though just a minute. Okay, I hope screen is visible now. Yes, even though stress and strain become 1/3 of their original value, their ratio becomes same. This is the concept. Okay, thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us look at the question number 2. Let Ys and Ya represent Young's modulus for steel and aluminium respectively. It is said that steel is more elastic than aluminium. Therefore, it follows that options: Young's modulus of steel is equal to Young's modulus of aluminium. Young's modulus of steel is less than Young's modulus of aluminium. Young's modulus of steel is greater than Young's modulus of aluminium, or Young's modulus of steel divided by Young's modulus of aluminium equal to 0. Okay, so let Ya be the Young's modulus of aluminium. Okay, Young's modulus of aluminium, and Ys be the Young's modulus of steel. Okay. So what we are given? Steel is more elastic than aluminium. Steel is more elastic than steel is more elastic than aluminium. So these three things we are given. Okay. So we need to identify the correct option. Right. So elasticity is more in the sense what? More elasticity in the sense the material which has more elasticity, which in the sense what? It undergo less deformation, or it receives less strain under the application of same stress. ಇಲ್ಲಿ steel is more elastic than aluminum ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. So steel suffers less strain than aluminum even under the application of same stress. ನಮಗೆ ಗೊತ್ತಿದೆ Young's modulus Y is equal to stress divided by strain. Right, stress divided by strain. So what we are given here? Stress is constant. Here stress is same. Applied stress is constant, right? So which implies what? Young's modulus is inversely proportional to strain. Young's modulus is inversely proportional to strain. I will move on to the next slide. Okay. Young's modulus, which is inversely proportional to strain, right? That means more strain means less Young's modulus. Okay. Or smaller, which implies what? Smaller strain, which implies larger Young's modulus. Correct? So which implies what? Smaller strain in the sense larger Young's modulus. So what we are given? Steel is more elastic than aluminium. That means steel stretches less. See, steel is more elastic andre steel undergo less deformation under the application of stress, and aluminium undergo more deformation under the application of same stress. Therefore, strain of the strain of steel is less than strain of aluminium. So now we will come to the Young's modulus. So which implies what we can do? Young's modulus of steel, which is equal to stress divided by, so which is smaller strain, alwa? Smaller strain, which is greater than stress, same stress divided by larger strain, which is equal to Young's modulus of aluminium. As we already know, Young's modulus is inversely proportional to strain agirodrinda. Steel receives a small strain. That's why smaller strain in the sense more Young's modulus, larger strain in the sense less Young's modulus. Okay, lesser Young's modulus. So the right answer is Young's modulus of steel is greater than Young's modulus of aluminium because Young's modulus is inversely proportional to strain. So steel suffers less strain under the application of constant stress. The stress here is constant, right? That's why Young's modulus of steel is greater than Young's modulus of aluminium. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solid. Let us see the question number 3. The edge of an aluminium cube is 10 centimeter long. One face of the cube is firmly fixed to a vertical wall. A mass of 100 kg is then attached to the opposite face of the cube. The vertical deflection of this face or shear modulus vertical deflection of this face is ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ shear modulus of aluminum is 25 GPa and acceleration due to gravity is equal to 10 meter per second square. Options: option A 4 into 10 to the power minus 5 meter, option B 4 into 10 to the power minus 6 meter, option C 4 into 10 to the power minus 7 meter, and option D 4 into 10 to the power minus 8 meter. So what we are given? Aluminium cube with edge length is 10 meter. Okay, we are given aluminium cube with edge length L equal to, I take it as L, which is equal to 10 centimeter. So ಇದನ್ನ ಮೀಟರ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ 1 centimeter is equal to or 100 centimeter is equal to 1 meter ಆಗಿರೋದ್ರಿಂದ 10 centimeter is equal to 0.1 meter ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಸೊ ಮಾಸ್ ಅಟ್ಯಾಚ್ಡ್ ಎಷ್ಟಾಯ್ತು? ಒನ್ ಫೇಸ್ ಆಫ್ ದ ಫಿಕ್ಸ್ಡ್ ಕ್ಯೂಬ್ ಈಸ್ ಒನ್ ಫೇಸ್ ಆಫ್ ದ ಕ್ಯೂಬ್ ಈಸ್ ಫಿಕ್ಸ್ಡ್ ಟು ವರ್ಟಿಕಲ್ ವಾಲ್. ಇಲ್ಲಿ ಈ ರೀತಿ ವರ್ಟಿಕಲ್ ವಾಲಿಗೆ ಕ್ಯೂಬ್ ಅನ್ನ ಫಿಕ್ಸ್ ಮಾಡ್ತಾರೆ ಆಯ್ತಾ. ಸೊ ಅಪೋಸಿಟ್ ಫೇಸಿಗೆ ಇಲ್ಲಿ 100 kg ಮಾಸ್ ಅನ್ನ ಅಟ್ಯಾಚ್ ಮಾಡ್ತಾರೆ. ಸೊ ಮಾಸ್ ಅಟ್ಯಾಚ್ಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 100 kg. Right. So acceleration due to gravity we are given 10 meter per second square. So shear modulus of aluminium which is equal to 25 gigapascal. Giga andre eshtayitu 25 into which is equal to 25 into 10 to the power 9 Pascal ಆಯ್ತು. Okay, Pascal in the sense 25 into 10 to the power 9 Newton per meter square ಆಯ್ತು. Okay, so this is the shear modulus. Okay, now what we need to find out? We need to find out vertical deflection. So vertical deflection of this face. So ಈ ರೀತಿ ಮಾಸ್ ಅನ್ನ ನಾವು 100 kg ಮಾಸ್ ಅನ್ನ ಕ್ಯೂಬಿನ ಫೇಸ್ಗೆ ಒಂದು ಫೇಸ್ಗೆ ಅಟ್ಯಾಚ್ ಮಾಡಿದಾಗ ಇಟ್ ವಿಲ್ ಅಂಡರ್ಗೋ ಡಿಫಾರ್ಮೇಶನ್. ಓಕೆ, ಸೊ ಸ್ಟ್ರೈನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ನಾವು ವರ್ಟಿಕಲ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಅನ್ನ ಕಂಡುಹಿಡಿಬೇಕು. ವರ್ಟಿಕಲ್ ಡಿಫ್ಲೆಕ್ಷನ್ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ನಾ ಈ ರೀತಿ ಡಿನೋಟ್ ಮಾಡ್ತೀನಿ ಡೋ ಅಂತ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ವಶನ್ ಮಾರ್ಕ್. ಸೊ ಇಲ್ಲಿ ಒಂದು ಕ್ಯೂಬ್ ಅನ್ನ ಈ ರೀತಿ ವಾಲಿಗೆ ಅಟ್ಯಾಚ್ ಮಾಡಿರ್ತಾರೆ. ಅದರ ಎಡ್ಜ್ ಏನು 10 ಸೆಂಟಿಮೀಟರ್ ಇರುತ್ತೆ. ಓಕೆ, then 100 kg mass is attached to opposite face like this. It undergo deformation or it suffers strain. So we need to calculate the vertical deflection. Vertically ಎಷ್ಟು ಡಿಫ್ಲೆಕ್ಟ್ ಆಯ್ತು ಅದು ಅಂತ ಕಂಡುಹಿಡಿಬೇಕು. ರೈಟ್, so let us try to find out. First, let us try to find out the applied force. Applied force acting on the cube is nothing but its weight, right? So force acting on the cube. ಈ ಕ್ಯೂಬ್ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಿರೋ ಫೋರ್ಸ್ ಏನು, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಅದರ ವೇಟ್ ಆಗಿರುತ್ತೆ ಅಲ್ವಾ. Force acting on this cube is nothing but its weight. Weight is due to acceleration due to gravity into mass, right? So force acting on this cube which is equal to mass into acceleration. Mass is 100 kg, acceleration due to gravity is 10 meter per second, which is equal to 1000 Newton. So force acting on the cube is 1000 Newton. Okay, I will move on to the next slide. So next, let us calculate the area of face of the cube. Okay, area of face of cube. So ಈ ಕ್ಯೂಬಿನ ಏರಿಯಾವನ್ನ ಕಂಡುಹಿಡಿಯೋಣ. ಈ ಒಂದು ಫೇಸಿನ ಏರಿಯಾವನ್ನ ಕಂಡುಹಿಡಿಯೋಣ. Let us calculate the area of this face of the cube. Okay, area of the face of the cube. We are given length as 10 centimeter long anta kottidare. That means 0.1 meter. So area andre L square, edge square alva, which is equal to 0.1 the whole square, which is equal to area is equal to 0.01 meter square ಆಯ್ತು. 0.01 meter square ಆಯ್ತು. So what is the shear modulus? Shear modulus is the ratio of shear stress divided by shear strain. Which is ನಾನು symbolically ಬರೀತೀನಿ, which is equal to shear stress is nothing but, as we already know, stress is equal to force divided by area, right? Stress is equal to stress in a direct formula ಏನು ಅಂದ್ರೆ force per area, which is equal to F divided by A. Strain is equal to what is strain? Vertical deflection dou divided by length, original length divided by vertical deflection, right? Original length, original edge length, idu vertical deflection divided by original edge length. This is the shear strain. Okay, ivaga namge vertical deflection beku. So rearrange this equation, then we will get vertical deflection as ille rearrange madidre neevu, it is given as ille rearrange madidre it is given as F into L, correct? F into L divided by eta into A agutte, correct? Eta into A agutte. So vertical deflection is given as F into L divided by eta into A agutte. So just substitute the value. So what is the force? 1000 Newton. Length is 0.1 meter, right? And this eta is given as ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? So it is equal to 25 gigapascal, which is equal to 25 into 10 to the power 9 Pascal into area is given as area is equal to L square, which is equal to 0.01 meter square. So ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ so 1000 can be written as 10 to the power 3. 10 to the power 3 into 0.1 is 10 to the power minus 1 divided by 25 into 10 to the power 9 into 0.01 ಅಂದ್ರೆ 10 to the power minus 2, right? So ನಾನು ಇಲ್ಲಿ ಮಾಡ್ತೀನಿ ಈ ಕಡೆ. So vertical deflection, which is equal to 10 to the power 3 into 10 to the power minus 1 divided by 25 into 10 to the power 9 into 0.01 andre it is nothing but 10 to the power minus 2 ಆಯ್ತು. So ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಯ್ತು? 10 to the power 3, 10 to the power 9. ಇಲ್ಲಿ ನ್ಯೂಮರೇಟರ್ ಅನ್ನ ಫಸ್ಟ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಣ. 10 to the power 2 ಉಳಿತು. ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ 10 to the power plus 9 into 10 to the power minus 2 ಅಂದ್ರೆ 10 to the power 25 into 10 to the power 7 ಉಳಿತು ಅಲ್ವಾ? It can be further simplified as 10 to the power 7. If it goes to numerator, 10 to the power, it will become 10 to the power minus 7. 10 to the power minus 7 plus 2 under 10 to the power minus 5 divided by 25 ಆಗುತ್ತೆ. So I erase this. So 10 to the power minus 5. So 1 by 25 means what? Which is equal to okay, I am going to erase this. Okay. So vertical deflection is came out to be 10 to the power minus 5 divided by 25, which is equal to 1 by 25 into 10 to the power minus 5, right? So 1 by 25 in the sense what? How much it is? 1 by 25 andre 1 by 25 means how much it is? 0.04 alwa. 1 divided by 25 in the sense 0.04. 0.04 into 10 to the power minus 5. It can be also written as ನಾನು ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. 2 ಡಿಜಿಟ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay, here which is equal to 4 into 10 to the power minus 7 meter. So vertical deflection is calculated as 4 into 10 to the power minus 7. So the correct answer is 4 into 10 to the power minus 7. Thank you. everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us calculate question number 4. The bulk modulus of a spherical object is B. I am repeating this question. Just a minute. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solid. Let us look at the question number 4. The bulk modulus of a spherical object is B. If it is subjected to uniform pressure P, the fractional decrease in the radius is options. Option A, P by B. Option B, P by 3B. Option C, 3P by B. And option D, B by 3P. Okay, what we are given? Bulk modulus of spherical object is B. Bulk modulus of spherical object is B, and applied uniform pressure is P. Pressure is P. Uniform pressure applied is P. What we need to find out? Fractional decrease in the radius. Fractional decrease in the radius we need to find out. Okay. So bulk modulus. What is bulk modulus? B is equal to pressure divided by, it is the ratio of pressure to volume strain. Pressure to volume strain alva. Bulk modulus is equal to pressure to volume strain. So volume strain andre it is the ratio of change in volume to original volume alva. So idanna nanu bids baritini. B is equal to formula pressure andre ನಾವು P anta ತಗೊಂಡಿದ್ದೀವಿ. Volume strain can be written as delta V, that means change in volume under the application of pressure divided by original volume. Okay, this is the formula for bulk modulus. Okay, since the pressure compresses the sphere, volume get decreased. Okay, so let us consider just modulus, not going to taking negative sign. Negative sign anna ignore ಮಾಡೋಣ ಆಯ್ತಾ. ಫಾರ್ ದಿಸ್ ಇನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಅಂತ ತಗೋಬೇಕು, ಅದನ್ನ ಇಗ್ನೋರ್ ಮಾಡೋಣ. ನೆಗೆಟಿವ್ ಸೈನ್ ಅನ್ನ ನಾವು ಇಗ್ನೋರ್ ಮಾಡೋಣ. ಓಕೆ, ಸೊ ಜಸ್ಟ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಸೊ ಸ್ಪೆರಿಕಲ್ ಏನು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ. ಸೊ ಪ್ರೆಷರ್, ಯೂನಿಫಾರ್ಮ್ ಪ್ರೆಷರ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಅದ್ರ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಸಫರ್ ಅ ಸ್ಟ್ರೇನ್. ಸೊ ವಾಟ್ ಈಸ್ ದ ವಾಲ್ಯೂಮ್ ಸ್ಟ್ರೇನ್ ಅಂತ ನೋಡ್ಬೇಕು. ಆಮೇಲೆ ಫ್ರಾಕ್ಷನಲ್ ಡಿಕ್ರೀಸ್ ಇನ್ ದ ರೇಡಿಯಸ್. ರೇಡಿಯಸ್ ಎಷ್ಟು ಕಡಿಮೆ ಆಯ್ತು? ಸೊ ಎಲ್ಲಾ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ಪ್ರೆಷರ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಫ್ರಾಕ್ಷನಲ್ ಡಿಕ್ರೀಸ್ ಇನ್ ರೇಡಿಯಸ್, ವಾಟ್ ಈಸ್ ದ ಫ್ರಾಕ್ಷನಲ್ ಡಿಕ್ರೀಸ್ ಇನ್ ರೇಡಿಯಸ್ ಅಂತ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಇವಾಗ ನಮ್ಗೆ ಸೊ ಇದನ್ನೇ ರೀಅರೇಂಜ್ ಮಾಡಿದ್ರೆ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಗೆಟ್? delta V by V is equal to pressure divided by bulk modulus anta baratta. Yes, pressure divided by bulk modulus. I go to next slide. Okay, delta V divided by V is equal to pressure divided by bulk modulus. So we already know volume of the sphere ಏನು 4 by 3 pi r square. Volume of the sphere, which is equal to V, capital V, which is equal to 4 by 3 pi into r cube. 4 by 3 pi r square alla, 4 by 3 pi r cube alva. So volume is equal to pi r cube. So differentiating this volume with respect to radius. Okay, So differentiating this volume with respect to radius. So ನಾನು dv by dr ಅಂತ ತಗೊಳ್ತೀನಿ, which is equal to 4 by 3 into pi into, so variable is radius, right? So radius ಅನ್ನು ನಾವು differentiate ಮಾಡಬೇಕು with respect to r. So differentiation of r cube is 3 into r square. ಸೊ ಇದನ್ನೇ ನಾನು ರಿಅರೇಂಜ್ ಮಾಡಿ ಬರೀತೀನಿ ಮಕ್ಕಳೇ. 4 by 3 pi, ಓಕೆ, ಆರ್ ಸ್ಕ್ವೇರ್. ನಾನು ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನೋಮಿನೇಟರ್ ಅನ್ನ ಆರ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ, 3 ಇಲ್ಲಿ ಬರೀತೀನಿ. ಓಕೆ, ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ 4 by 3 pi ಆರ್ ಕ್ಯೂಬ್ divided by r into 3. So which is written as, so 4 by 3 pi r cube. ಇದು ಏನಂತ ಬರಿಬಹುದು ನಾವು? 4 by 3 pi r cube ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಅಂತ ಬರಿಬಹುದು. So which can be written as volume divided by r into 3, which is equal to 3v by r ಅಲ್ವಾ? Therefore dv by dr change in volume with respect to radius, dv by dr equal to 3v by r ಅಂತ ಬರಿಬಹುದು. ಕರೆಕ್ಟಾ? So I am going to erase this. You can note down this. Okay, I am going to erase this. Okay, which expression we got now? dv by dr equal to so what was the expression? 3v by r. Yes, 3v by r. So ಇದನ್ನೇ rearrange ಮಾಡಿದ್ರೆ dv by v is equal to dr, 3 times dr divided by r ಅಂತ ಬರಿಬಹುದು. ಸೊ ನಾನು dv ಅನ್ನ ಡೆಲ್ಟಾ v ಅಂತ ತಗೊಂಡಿದ್ದೆ ಅಲ್ವಾ? ಸೊ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ dv equal to ಡೆಲ್ಟಾ v ಅಂತ ತಗೊಂಡಿದ್ದೆ ಅಲ್ವಾ? dr ಅನ್ನ ನಾನು ಡೆಲ್ಟಾ r ಅಂತ ತಗೊಳ್ತೀನಿ. ಓಕೆ, ಸೊ ಜಸ್ಟ್ ನಾನು ಸೈನ್ ಅನ್ನ ಚೇಂಜ್ ಮಾಡಿದೆ, ಆಯ್ತಾ? ಸೈನ್ ಅಲ್ಲ, ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ನೊಟೇಷನ್ ಅನ್ನ ಈ ರೀತಿ ತಕೊಂಡೆ. ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್ ಹಿಯರ್. ನಾನು ಡಿವಿ ಅನ್ನ ಡೆಲ್ಟಾ ವಿ ಅಂತ ತಗೊಳ್ತೀನಿ, ಯಾಕೆಂದ್ರೆ ಪ್ರೀವಿಯಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನಾವು ಈ ರೀತಿನೇ ತಗೊಂಡಿದ್ವಿ ಅಲ್ವಾ? ಡೆಲ್ಟಾ ವಿ ಡಿವೈಡೆಡ್ ಬೈ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 3 ಇಂಟು ಡೆಲ್ಟಾ ಆರ್, ಡಿ ಆರ್ ಅನ್ನ ಡೆಲ್ಟಾ ಆರ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಅಂತ ತಗೊಳ್ತೀನಿ. Okay, so what is delta r? It is decrease in radius. Delta v means decrease in volume, right? So what is delta v by v? It is fractional decrease in volume. Delta r by r means fractional decrease in radius, right? So ivaga what was the expression? Namge yen ittu? What is it? We already know that delta v by v is equal to ಏನಂತ ಸಿಕ್ಕಿತ್ತು ನಮ್ಗೆ? ಡೆಲ್ಟಾ ವಿ ಬೈ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಬೈ ಬಿ ಅಂತ ಮಾಡಿದ್ವಾ ನಾವು? ಜಸ್ಟ್ ಗೋ ಟು ದ ಲಾಸ್ಟ್ ಸ್ಲೈಡ್. ಡೆಲ್ಟಾ ವಿ ಬೈ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಬೈ ಬಿ ಅಲ್ವಾ? ಸೊ ಡೆಲ್ಟಾ ವಿ ಬೈ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಬೈ ಬಿ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 3 times delta r divided by r. Okay, 3 times delta r divided by r. Okay, so which implies delta r divided by r is equal to ಏನಾಗುತ್ತೆ? delta r divided by r is equal to p by d times b ಆಗುತ್ತೆ. So what is delta r divided by r? It is fractional decrease in radius. Fractional decrease in radius. What is it? Delta R by R or dr by r. Right? So the correct answer is option B, P divided by 3B, which is equal to fractional decrease in radius. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us look at the question number 5. Compressibility of water is 5 into 10 to the power minus 10 meters square per Newton. Change in the volume of 100 ml of water is subjected to 15 into 10 to the power 6 Pascal pressure will be options. Option A increased by 0.75 ml. Option B decreased by 1.50 ml. Option C increased by 1.50 ml. And option D decreased by 0.75 ml. Okay. So water is there. So pressure is applied to the water. It undergo compression. Okay, it undergo compression. So compressibility of water andre it is the measure of water response to the applied pressure. So pressure ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದಾಗ ವಾಟರ್ ಯಾವ ರೀತಿ ರಿಯಾಕ್ಟ್ ಮಾಡುತ್ತೆ ಅಥವಾ ಯಾವ ರೀತಿ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕಿರೋ ಒಂದು ಫ್ಯಾಕ್ಟರ್ ಕಾಂಪ್ರೆಸಿಬಿಲಿಟಿ ಅಂದ್ರೆ. ಓಕೆ, so what we are given here, compressibility of water, ಇದನ್ನ ಗ್ರೀಕ್ ಲೆಟರ್ ಈ ರೀತಿ ಒಂದು ಲೆಟರ್ ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ. ಕಾಂಪ್ರೆಸಿಬಿಲಿಟಿ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, 5 into 10 to the power minus 10 ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ನ್ಯೂಟನ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ವಾಟರ್ದು, ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಇಸ್ 100 ml. 100 ml ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಪ್ಲೈಡ್ ಪ್ರೆಷರ್ ಈಕ್ವಲ್ ಟು 15 into 10 to the power 6 Pascal ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ರೈಟ್, ವಾಟ್ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್, ಡೆಲ್ಟಾ ವಿ ಅನ್ನ ಕಂಡುಹಿಡಿಯಬೇಕು. ಓಕೆ, ಚೇಂಜ್ ಇನ್ ವಾಲ್ಯೂಮ್ ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್. Change in volume, delta V or dV or delta V is equal to question mark. Okay, this is the question mark. Next nodana. First compressibility andre enu? What is the compressibility of water andre nodana. So it is defined as the fractional change in the volume per unit pressure. Okay, it is defined as it is the fractional change in volume per unit pressure. Okay, ಇದನ್ನ ನಾವು mathematically ಯಾವ ರೀತಿ ಬರೀಬಹುದು, compressibility can be written as fractional change in the volume is delta V divided by V. Right, fractional change in the volume andre delta V, that is change in the volume divided by initial volume per unit pressure ಅಂದ್ರೆ ನಾನು P ಅಂತ ಬರಿತೀನಿ. ಓಕೆ, ಸೊ ಇದನ್ನೇ ನಾನು ಸಿಂಪಲ್ ಆಗಿ ಡಿ ವಿ ಬೈ ವಿ ಇಂಟು ಪಿ ಅಂತಾನು ಬರಿಬಹುದು. ಓಕೆ, ಸೊ ನಾವಿಲ್ಲಿ ಡೆಲ್ಟಾ ವಿನೇ ತಗೊಳ್ಳೋಣ. ಸೊ ವಾಟ್ ಈಸ್ ದ compressibility of water? Let me repeat, it is the change in the fractional change in the volume per unit pressure ಅಂತ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಸೊ ಮ್ಯಾಥಮೆಟಿಕಲಿ ಈ ರೀತಿ ಬರೀಬಹುದು. ಸೊ ಡೆಲ್ಟಾ ವಿ, that is change in the volume, can be defined as this compressibility into volume into pressure. So just substitute ಮಾಡಿ. compressibility ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, 5 into 10 to the power minus 10 meter square per Newton ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Initial volume is given as 100 ml and applied pressure is given as 15 into 10 to the power 6 Pascal. Just to simplify this, we will get the answer. So it is equal to 100 into 5 is 500, 500 into 15 into 10 to the power minus 10 into 10 to the power plus 6 andre which is equal to 10 to the power minus 4 ಆಯ್ತು. So 500 into 15 ಅಂದ್ರೆ 15 into 0 0 15 into 0 0 15 into 5 75 7500 into 10 to the power minus 4 ಆಯ್ತಾ. ಸೊ 10 to the power minus 4 ಆಯ್ತು. ಸೊ ಇದನ್ನ ನಾವು 10 to the power minus 4 ಅಂದ್ರೆ ನಾವು ಇದನ್ನ ರೀಅರೇಂಜ್ ಮಾಡಿ ಬರೆದ್ರೆ 1 2 3 4. ಓಕೆ, 4 ಡೆಸಿಮಲ್ಸ್ ಪಾಯಿಂಟ್ ಅನ್ನ ನಾವು ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ 4 ಡಿಜಿಟ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಎಷ್ಟು ಬರಿಬಹುದು? 4 ಡಿಜಿಟ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅನ್ನ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ it will be 0.75 ml. Okay, 0.75 ml. So since pressure compresses the water, there should be decrease in volume. Pressure ಏನ್ ಮಾಡುತ್ತೆ? ಅಪ್ಲೈಡ್ ಪ್ರೆಷರ್ ಕಾಂಪ್ರೆಸಸ್ ದ ವಾಟರ್. ವಾಟರ್ ಅನ್ನ ಕಾಂಪ್ರೆಸ್ ಮಾಡುತ್ತೆ ಅಲ್ವಾ, ಎಕ್ಸ್ಪಾಂಡ್ ಅಂತೂ ಮಾಡಲ್ಲ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಆದಾಗ. ಇಂಟರ್ನಲ್ ಪ್ರೆಷರ್ ಇದ್ರಷ್ಟೇ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಅಪ್ಲೈಡ್ ಪ್ರೆಷರ್ ಕಾಂಪ್ರೆಸಸ್ ದ ವಾಟರ್, ದಟ್ಸ್ ವೈ ಡಿಕ್ರೀಸ್ ಇನ್ ವಾಲ್ಯೂಮ್. ಸೊ 75 ml decrease. So the right answer here is option D, decreased by 0.775 ml. Not 75, it is 0.75 ml decrease. Okay, thank you. Hello everyone. Welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solid. Let us look at the question number 6. Two wires of same material and length but diameters in the ratio 1:2 are stretched by the same load. The ratio of elastic potential energy per unit volume of the two wires is options. Option A 1:1, option B 2:1, and option C 4:1, and option D 16:1. So there are two wires made up of same material. Here you can see in the picture. So wire 1, W1 and W2, two wires made up of same material. Diameter ratio ಏನಿರುತ್ತೆ 1:2 ಇದೆ. So D1 equal to D ಇದ್ರೆ D2 equal to 2 times D ಇದೆ. So length is same. Both wires have same length and same pressure is applied. Same load is applied. So energy density U1 is to U2 equal to question mark. Energy density means for elastic potential energy per unit volume we need to calculate. Okay. Same length ಇದೆ ಮತ್ತೆ same material ಇದೆ. So diameters are in the ratio 1:2. Okay. So both are stretched by same load. ಇಲ್ಲಿ ನಿಮಗೆ ಪಿಕ್ಚರ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಕಾಣಿಸುತ್ತೆ. ಓಕೆ. ಸೊ ನಮಗೆ ಈಗ elastic potential energy per unit volume ಅಥವಾ energy density. Elastic potential energy per unit volume of energy density. Energy density. I write it as U is equal to half into stress into strain. Elastic potential energy per unit volume, that is energy density U is equal to half into stress into strain. Okay. So according to Hooke's law the prakara, so ನಾನು ಡೀಟೇಲ್ ಆಗಿ ಬರೀತೀನಿ ಇಲ್ಲಿ. Energy density which is equal to U is equal to half into stress into strain. Half into stress into strain. So Hooke's law the prakara, stress by strain is equal to Young's modulus. It is a constant which is equal to Young's modulus. Alva? Stress by strain is equal to Young's modulus. So strain can be written as, which implies strain can be written as, strain andre yav riti baribodu, which is equal to stress by Young's modulus. Why? Young's modulus anta baribodu alva? So illi strain ಜಾಗದಲ್ಲಿ ನಾವು stress by y anta baribodu. Therefore energy density U is equal to half into stress into strain ಜಾಗದಲ್ಲಿ ಏನನ್ನ ಬರಿಬಹುದು ನಾವು stress by y, which is equal to stress into stress means stress square divided by 2y. Alva? Stress square divided by 2y. Stress square divided by 2y, which implies what? Stress is 2y is constant here, which is equal to U is equal to constant into stress square. Because Young's modulus is constant, because ಎರಡು ವೈರು ಕೂಡ ಸೇಮ್ ಮಟೀರಿಯಲ್ ಇಂದ ಮಾಡಿದೆ. Therefore y constant here. Y is constant. Young's modulus is same for both wires. That's why U is equal to constant into stress square, which implies what? U is, now next baritane, energy density. Energy density, which is equal to U, directly proportional to square of the stress. Alva, take it as equation number 1. Okay. So navivaga stress anna yav riti baribodu? Stress can be written as force per area. Stress can be written as force per area. Here force is constant. Alva, constant force is applied. So which is equal to constant force divided by area, right? Which implies what? Stress is inversely proportional to area. Stress is inversely proportional to area, right? Take it as equation number 2. Okay. Now, area is equal to area of the wire. So ಇಲ್ಲಿ ನಾನು diagram ಹಾಕ್ತೀನಿ. Cross sectional area of the wire is in circular shape alva, cross sectional area. So this area is equal to ಇದು diameter ಆಯ್ತು ಅಲ್ವಾ, ಈ ಲೆಂತ್ ಏನಾಯ್ತು diameter ಆಯ್ತು, ಕರೆಕ್ಟಾ? ಸೊ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ ಏನಾಯ್ತು, which is equal to pi r square ಆಯ್ತು ಅಲ್ವಾ, pi r square ಆಯ್ತು. R is equal to d by 2, which is equal to pi d by 2 the whole square, which is equal to pi d square by 4 ಆಯ್ತು, ಕರೆಕ್ಟ್? Radius is half of diameter, so I write radius as d by 2, which is equal to pi d square by 4, right? So which implies what? Area, cross sectional area, this area of wire is directly proportional to square of the diameter. Area is directly proportional to square of the diameter. Take it as equation number 3. So what we can write here? So ಇಲ್ಲಿ ನೋಡಿ, stress is inversely proportional to area. Area is directly proportional to square of the diameter. So we can find the, or we can relate the stress and diameter now, which implies stress is inversely proportional to area, and which is inversely proportional to diameter square, right? ಈ ರೀತಿ ನಾವು ರಿಲೇಟ್ ಮಾಡಬಹುದು, correct? No, stress is inversely proportional to area, which implies stress is inversely proportional to square of the diameter. Take it as equation number 4. Stress is inversely proportional to square of the diameter. What we are given now? So what we are given, d1 is to, we are given d1 is to d2 ratio is 1 is to 2 ಅಲ್ವಾ, ಅಲ್ಲ ಡಯಾಮೀಟರ್ ರೇಷಿಯೋ ಇಸ್ 1 is to 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. therefore area ratio ಏನಾಗುತ್ತೆ, area is directly proportional to square of the diameter ಅಲ್ವಾ. ಸೊ ನಾನು ಇದನ್ನ ಇರೇಸ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಓಕೆ. ಸೊ ಈ ರಿಲೇಷನ್ ಅನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ. ನಾನು ಓಕೆ. ಸೊ ಇವಾಗ d1 is to d2 ರೇಷಿಯೋ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, 1 is to 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ವಿ ಆರ್ ಆಲ್ರೆಡಿ ಗಿವನ್ 1 is to 2. therefore Area ratio ಏನಾಯ್ತು A1:A2. So cross section area ratio ಏನಾಯ್ತು ಹಾಗಿದ್ರೆ ಇದ್ರದ್ದು D1 ಇದೆ ಮತ್ತೊಂದು ವೈರ್ದು D2 ಇದೆ. So ಈ cross section area ratio ಏನಾಯ್ತು ಹಾಗಿದ್ರೆ what is the area of cross section then, which is equal to ಏನಾಯ್ತು we already know A is directly proportional to D square, which implies D is directly proportional to A square, right? So sorry. Okay. So A is directly proportional to D square, alva? Area is directly proportional to D square. We are given. That's why D1 is to D2. Andre ಏನಾಯ್ತು D1 square is to D2 square ಆಯ್ತು, which is equal to ಏನಾಯ್ತು D1 is 1 square is to 2 square, which is equal to 1 is to 4 ಆಯ್ತು, right? 1 is to 4 ಆಯ್ತು. So what we are given now, therefore we already know stress is inversely proportional to area, right? Stress is inversely proportional to area. ಹಾಗಾಗಿ ಏನ್ ಬರಿಬಹುದು ನಾವು stress 1 divided by stress 2 is equal to stress 1 divided by stress 2 is equal to area 2 divided by area 1. Area 2 is what? Area 2 is 4 divided by area 1 is 1. Therefore, stress 2 divided by stress 1 is equal to 4 is to 1 ಆಯ್ತು, right? 4 is to 1 ಆಯ್ತು. So I am going to erase this. I am going to do this in next slide. It should be stress 1 alva. Okay, I am going to take the next slide. Therefore, what we have determined, stress 1 divided by stress 2, which is equal to 4 is to 1, which implies stress 1 is to stress 2 equal to 4 is to 1 ಆಯ್ತು, correcta? So what we are given, U is directly proportional to, that is elastic potential energy per unit volume, which is directly proportional to stress square from equation number 1. Recall the equation number 1. So we know that U is directly proportional to stress square. Therefore, U1 is to U2, which is equal to stress 1 square divided by stress 2 square. Stress 1 square divided by stress 2 square. Stress 1 andre 4, stress 2 andre corresponding ratio is 1. 4 square is to 1 square, which is equal to U1 divided by U2 is equal to 16 divided by 1. Okay, which implies U1 is to U2 is equal to 16 is to 1. Correcta? So the right answer here is the ratio of elastic energy, potential energy per unit volume, or energy density will be in the ratio 16 is to 1. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solid. Let us look at the question number 7. A spring is generally made up of steel rather than copper because option A, steel is harder than copper. Option B, steel is not affected by weather. Option C, steel is inelastic and copper is elastic. Steel is more elastic than copper. So which one is the right answer we have to identify? Spring. So what is the characteristics of a good spring? So good spring should have regain its original shape even after the load is removed. Okay, ಇದನ್ನ elasticity ಅಂತ ಹೇಳ್ತೀವಿ. It should regain its original shape even after the removal of load. Then it is called a good spring. ಸೊ ಲೋಡನ್ನ ರಿಮೂವ್ ಮಾಡಿದ್ಮೇಲೆ ಅದು ಏನ್ ಮಾಡ್ಬೇಕು, ತನ್ನ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅನ್ನ ಪುನಃ ತಂದ್ಕೋಬೇಕು. ಸೊ ಲೋಡ್ ಅನ್ನ ಹಾಕಿದಾಗ ಅದು ಕಾಂಪ್ರೆಸ್ ಆಗುತ್ತೆ, ಅಥವಾ ಫೋರ್ಸ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಲೋಡ್ ಅನ್ನ ಹಾಕಿದಾಗ ಅದು ಎಕ್ಸ್ಟೆಂಡ್ ಆಗುತ್ತೆ ಅಥವಾ ಕಾಂಪ್ರೆಸ್ ಆಗುತ್ತೆ. ಸೊ ಪ್ರೆಷರ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಕಾಂಪ್ರೆಸ್ ಆಗ್ಬಹುದು ಅಥವಾ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗ್ಬಹುದು. ಸೊ ಆ ಲೋಡ್ ಅಥವಾ ಪ್ರೆಷರ್ ಅಥವಾ ಫೋರ್ಸ್ ಅನ್ನ ನಾವು ರಿಮೂವ್ ಮಾಡಿದಾಗ ಅದು ತನ್ನ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅನ್ನ ರೀಗೇನ್ ಮಾಡಬೇಕು. ಅದು ಹಂಗಿದ್ರೆ ಅದನ್ನ ನಾವು ಗುಡ್ ಸ್ಪ್ರಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದು ಇಲಾಸ್ಟಿಕ್ ಡಿಫಾರ್ಮೇಶನ್ ಅನ್ನ ಹೊಂದಬೇಕು ಅಂತ ಆಯ್ತು, ಅಂದ್ರೆ ಇಲಾಸ್ಟಿಸಿಟಿ ಇರಬೇಕು. ಸೊ ಗುಡ್ ಇಲಾಸ್ಟಿಸಿಟಿ ಅಂದ್ರೆ elasticity. If elasticity is more, in the sense what? Young's modulus is more. Young's modulus also more. If elasticity is more in the sense, Young's modulus also more. ಅಲ್ವಾ? ಹೈ Young's modulus ಇರುತ್ತೆ. ಯಾವಾಗ ಇಲಾಸ್ಟಿಸಿಟಿ ಒಂದು ಮಟೀರಿಯಲ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂದ್ರೆ ಅದರ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅನ್ನ ರೀಗೇನ್ ಮಾಡುವಂತಹ ಗುಣ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಆವಾಗ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಅಂದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಿದೆ. ನೆಕ್ಸ್ಟ್ ಹೋಗ್ತೀನಿ. ಇಲಾಸ್ಟಿಸಿಟಿ directly proportional to Young's modulus, alva. So elasticity more means Young's modulus more. So Young's modulus Y is equal to stress divided by strain, alva. So we already know this, which implies material which have higher Young's modulus will suffer less strain, alva. So what we can write here? Material with higher Young's modulus is more elastic and suffers less strain. So if Young's modulus is more, which implies strain will be less. Strain will be less, which implies elasticity is more. Okay. Young's modulus and elasticity directly proportional to each other, and Young's modulus and strain both are inversely proportional to each other. Just see here, Young's modulus inversely proportional to strain. So if more will be less, then elasticity will be more, then it will regain its shape after removal of load quickly or more efficiently. Quickly annodakkinta more efficiently or more effectively, we can say. So what is the Young's modulus of steel? So for steel, Young's modulus ಎಷ್ಟಿದೆ? Nearly equal to 2 into 10 to the power 11 Newton per meter square ಇದೆ ಫಾರ್ ಸ್ಟೀಲ್ಗೆ. ಕಾಪರ್ಗೆ Young's modulus ಎಷ್ಟಿದೆ? It is 1.1 into 10 to the power 11 Newton per meter square ಇದೆ. ಸೊ ಯಾವುದಕ್ಕೆ Young's modulus ಜಾಸ್ತಿ ಇದ್ದಾಗಾಯ್ತು? Steel has more Young's modulus. That's why steel has more elastic property and it will suffer less strain. So it will have the tendency to regain its original property more effectively. So right option here is option D. Steel is more elastic than copper. That's why generally uh, steel is used in preparation of spring, because this spring should have more elasticity. Okay, thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijayshri. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us look at the question number 8. A wire breaks under the force of 500 kg weight. What braking force is required for another wire of same material and length but having half the cross section area of first? Half the cross section area ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Option A 500 kg weight, option B 200 kg WT, option C 1000 kg WT, and option D 7750 kg WT. So wire breaks under the force 500 kg weight. Andre breaking force of first wire, ಬ್ರೇಕಿಂಗ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ವೈರ್ ಅನ್ನ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಫೋರ್ಸ್, ಬ್ರೇಕಿಂಗ್ ಫೋರ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ವೈರ್, let it be F1, which is equal to 500 kg WT. Okay, so ಮತ್ತೊಂದು ವೈರ್ ಇರುತ್ತೆ. So another wire and same length, but cross section area is half. Okay, so second wire has same material, same length, and half the cross section area. So let cross section area of first wire B ಏನ್ ಇಟ್ಕೊಳ್ಳೋಣ ನಾವು A1 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ, and cross section area second wire. ಏನಾಗುತ್ತೆ cross section area of second wire, it will be A2 equal to half of cross section area of first wire, so it is equal to A1 by 2 ಆಗುತ್ತೆ, right? So this is we are given, we need to calculate the, what we need to calculate, we need to calculate breaking force of the second wire. Okay, breaking force of second wire, the wire 2. Okay, ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎರಡು ವೈರ್ದು ಮಟೀರಿಯಲ್ ಸೇಮ್ ಇರುತ್ತೆ, ಲೆಂತ್ ಸೇಮ್ ಇರುತ್ತೆ, ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಸೆಕೆಂಡ್ ವೈರ್ದು ಫಸ್ಟ್ ವೈರ್ಗಿಂತ ಅರ್ಧ ಕಡಿಮೆ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ cross section area of second wire is half of the cross section area of first wire. We need to calculate the breaking force of second wire. Breaking force of second wire. First wire ge breaking force 500 kg W2 anta kottidare, WT anta kottidare. So what we know that breaking stress which is equal to ಏನು, ಬ್ರೇಕಿಂಗ್ ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೆ ನಾನು ಈ ರೀತಿ ಸಿಗ್ಮಾ ಬಿ ಅಂತ ಒಂದು ನೋಟೇಶನ್ ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀನಿ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫೋರ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಏರಿಯಾ. ಓಕೆ, ಸೊ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಹಿಯರ್ F2, breaking stress of second is the question mark, right? So breaking stress is equal to sigma b is equal to force divided by area. Okay, now ಈಗ ನೋಡಿ ಇಲ್ಲಿ, so material is same, so breaking stress is constant. Since material same ಇದೆ ನೋಡಿ ಇಲ್ಲಿ, ಸೇಮ್ ಮಟೀರಿಯಲ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, for same material sigma b is constant. So for same material sigma b is constant, that is breaking stress, that is force divided by area is constant, which implies F by A, which is equal to constant, which implies what, force is directly proportional to area alwa. So now general agi force is directly proportional to area anta baredid nodayitu. So take it as equation number 1 aita. So ivaga force is directly proportional to area of cross section anta iddaga, so breaking force of the first wire divided by breaking force of the second wire, can we write like this, cross section area of second wire, cross section area of first wire, cross section area of first wire divided by cross section area of second wire. Can we write like this? Yes, we can write like this, because force is directly proportional to area, right? Area of the force is directly proportional to area. So directly proportional quantities anna ನಾವು ಈ ರೀತಿ ಬರಿಬಹುದು, ರೂಲ್ ಪ್ರಕಾರ ಈ ರೀತಿ ಬರಿಬಹುದು, right? So let us substitute the value. F1 we are given as F1 is to 500 kg weight ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, A2 is equal to A1 divided by 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, F2 is question mark, right? So ಇವಾಗ ಇದನ್ನ ನಾವು F1 ಅಂದ್ರೆ 500 ಆಯ್ತು, F2 we don't know, A1 is keep it as A1, A2 is equal to A1 by 2 ಅಲ್ವಾ. ಸೊ A2 ಜಾಗದಲ್ಲಿ ನಾನು A1 by 2 ಅಂತ ಬರೀತೀನಿ, so which is equal to 2 times 2 ಅಂತ ಆಯ್ತು. So A1 get cancelled, 2 goes to numerator, so 500 divided by F2 is equal to 2 ಆಯ್ತು ಅಲ್ವಾ. ಸೊ ಈ ಕಡೆ ಬರೀತೀನಿ, 500 divided by F2 is equal to 2 ಆಯ್ತು, right? Therefore which implies F2 is equal to 500 divided by 2, which is equal to 250 kg weight ಆಯ್ತು, right? 250 kg weight ಆಯ್ತು. So the correct answer is answer B, option B, 250 kg weight is the correct answer. Okay, thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solid. Let us look at the question number 9. A rod of uniform density and length L subjected to a horizontal accelerating pull on the frictionless surface. Find the magnitude of the stress at a midpoint of cross section. Options. Option A 2 by 3, this density into A into L. Option B, density into A into L. Option C, 1 by 2 density into A into L. Option D, 2 times density into A into L. So what we are given? Rod with density. Density of the rod is this rho ಅಂತ ಹೇಳ್ತೀವ, Greek letter it is. Okay. So rod ಅನ್ನ ನಾವು ನೋಡ್ತಾ ಇದೀವಿ ಇಲ್ಲಿ. ಸೊ ಸರ್ಫೇಸ್ ಇಸ್ ಫ್ರಿಕ್ಷನ್ಲೆಸ್ ಸರ್ಫೇಸ್ ಆಯ್ತಾ, ಸ್ಮೂತ್ ಸರ್ಫೇಸ್ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿಕೊಳ್ಳಿ. ಅಂಡ್ ಲೆಂತ್ ಇಸ್ ಲೆಂತ್ ಆಫ್ ದ ವೈರ್, ಲೆಂತ್ ಆಫ್ ದ ವೈರ್ ಇಸ್ ಎಲ್, ರೈಟ್. ರಾಡ್ ಈಸ್ pulled with a horizontal accelerating pull on a frictionless surface. Surface is frictionless. So acceleration ಏನಾಯ್ತು, rod is pulled horizontally and moves with the acceleration A. So acceleration of the rod will be A. Okay, rod is pulled horizontally, so it will acquire a acceleration A. So we need to calculate the stress at midpoint, at midpoint cross section, which is the question mark, So pulling force is in this direction, body acquires the acceleration in forward direction only. Okay, midpoint of cross section alli ನಾವು ಏನು ಕಂಡುಹಿಡಿಬೇಕು, stress ಅನ್ನ ಕಂಡುಹಿಡಿಬೇಕು. We need to identify the stress. Okay, so what is the formula for stress? Stress is equal to ಏನು, stress is equal to force divided by area, right? Stress is equal to force divided by area, area of cross section. Stress is equal to force divided by applied force divided by area of cross section. I write force as F and area as A. Okay. ಸೊ ಆಮೇಲೆ ಏನ್ ಮಾಡ್ತಾರೆ, ಈ ರಾಡ್ ಅನ್ನ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಮಿಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಟ್ ಮಾಡಬೇಕು. ಇಮ್ಯಾಜಿನ್ ರಾಡ್ ಈಸ್ ಕಟ್ ಅಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಮಿಡ್ ಪಾಯಿಂಟ್. ರಾಡ್ ಅನ್ನ ಮಿಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಏನ್ ಬರೆಯೋಣ, ಕಟ್ ದ ರಾಡ್ at its midpoint. Okay, so left half, therefore half length becomes half ಅಲ್ವಾ. ಸೊ ಈ ರೀತಿ ನಾವು ರಾಡ್ ಅನ್ನ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಮಿಡ್ಲ್ ಅಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಹಾಫ್ ಲೆಂತ್ ಏನಾಗುತ್ತೆ, L/2. ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಇಸ್ L, half length is equal to L/2. So volume ಏನಾಗುತ್ತೆ, therefore volume ಏನಾಗುತ್ತೆ, volume becomes ಏನಾಗುತ್ತೆ, ವಾಲ್ಯೂಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು, ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ಬರೀತೇನೆ, ವಾಲ್ಯೂಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಲ್ ಆಗಿತ್ತು ಅಲ್ವಾ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು, L ಅಂದ್ರೆ L² ಇಂಟು L ಆಯ್ತು. ಸೊ L² ಈಸ್ ಏರಿಯಾ ಇಂಟು L ಆಯ್ತು ಅಲ್ವಾ. ಸೊ ವಾಲ್ಯೂಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏರಿಯಾ ಇಂಟು L ಅಲ್ವಾ. ಸೊ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಏನಾಯ್ತು, ಸೇಮ್ ಇದೆ. ಈ ರಾಡ್ ಅನ್ನ ನಾವು ಇಲ್ಲಿ ಕಟ್ ಮಾಡಿದಾಗ ನೋಡಿ, ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ವಿ ಕಟ್ ದ ರಾಡ್ at mid point. Cross section area remains same. Here area of cross section, this cross section area remains same. But length ಏನಾಗುತ್ತೆ, ಅರ್ಧ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ ಆಗಿದ್ರೆ, cross section area remains same but length becomes half. So volume is equal to A into L/2. Right. So this is the new volume. So mass ಏನಾಗುತ್ತೆ ಆಗಿದ್ರೆ, what is the mass? ಮಾಸ್ ನಮಗೆ ಗೊತ್ತಿದೆ ಫಾರ್ಮುಲಾ ಏನು, ಡೆನ್ಸಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮಾಸ್ ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್ ಅಲ್ವಾ. ಡೆನ್ಸಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮಾಸ್ ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್, ವಿಚ್ ಇಂಪ್ಲೈಸ್ ಮಾಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೆನ್ಸಿಟಿ ಇಂಟು volume. So density will remain same. When you cut the rod at the exactly midpoint, density will remain same. Density is this rho, volume is this one, which is into A into L/2 ಆಯ್ತು. So mass is equal to ಏನಾಯ್ತು, rho into A into L/2 ಆಯ್ತು. Right. So ಇವಾಗ, so note down this. I am going to erase this. Okay, I am going to erase this. Okay. So mass ಏನಾಯ್ತು ಹಾಗಿದ್ರೆ, mass is equal to, what was the mass? It is equal to density into area into length divided by 2. It was the new mass when we cut the rod at exactly middle. Okay, midpoint ಅಲ್ಲಿ ನಾವು ರಾಡ್ ಅನ್ನ ಕಟ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಮಾಸ್ ಏನಾಯ್ತು, ಡೆನ್ಸಿಟಿ ಇಂಟು ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಇಂಟು L/2 ಆಯ್ತು. ರೈಟ್. ಸೊ ಇವಾಗ apply the Newton's second law. What is, according to Newton's second law, force is equal to mass into acceleration, right? Newton's second law the prakara, force is equal to mass into acceleration. So what is the given mass here, which is equal to this rho into A into L/2 into Acceleration. Acceleration means, so pulling force creates acceleration A alwa. Now previous slide alli nodidvi. Acceleration is A anta. So when you pull the rod by force F, it will accelerate through acceleration A anta ಮಾಡಿದ್ವಿ ಅಲ್ವಾ. ಸೊ ಇವಾಗ ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು ಆಗಿದ್ರೆ, ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ ಇಂಟು ಎ ಇಂಟು ಎಲ್ ಇಂಟು ಎ ಡಿವೈಡೆಡ್ ಬೈ 2 ಆಯ್ತು. ಸೊ ನೌ ವಿ ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಸ್ಟ್ರೆಸ್, ರೈಟ್. ಸ್ಟ್ರೆಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು ಆಗಿದ್ರೆ, stress is equal to force divided by area. So what is force here? Force is rho into A into L into acceleration divided by 2 divided by area is what? Area is A. Cross section area remains same. ನೀವು ರಾಡ್ ಅನ್ನ ಕಟ್ ಮಾಡಿದ್ರು ಕೂಡ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಏನಿರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ. It will remain same. So simplify this. So cancel out A and A. So remaining is ಏನಾಯ್ತು ಈಗ, ರೋ ಇಂಟು ಎಲ್ ಇಂಟು ಎ ಡಿವೈಡೆಡ್ ಬೈ 2. So stress is equal to ರೋ ಇಂಟು ಎಲ್ ಇಂಟು ಎ ಡಿವೈಡೆಡ್ ಬೈ 2. So new stress is equal to 1/2 into ರೋ ಇಂಟು ಎ ಇಂಟು ಎಲ್. ಸೊ ಇದನ್ನೇ ನಾವು ಮಾಡಿಫೈ ಮಾಡಿ ಈ ರೀತಿನೂ ಬರಿಬಹುದು, 1/2 into ರೋ ಇಂಟು ಎ ಇಂಟು ಎಲ್. So the right answer is option C, 1/2 into rho into A into L. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijay. We are discussing Lba-Kcet questions of the chapter Mechanical Properties of Solids. Let us look at the question number 10. An elastic spring has length of a meters under a 4 Newton load and B meters, A meters, okay, A meters under 4 Newton load and B meters under 5 Newton load. Find its length when 9 Newton force is applied. Okay, options. Option A plus B. Option B 9B minus 9A. Options B 5B minus 4A. And option D 4A minus 5B. So here you can see the elastic spring. So three cases you can see. So this is length A. Length A of the spring under 4 Newton load. Length B of the spring is under 5 Newton load. What is the length of the spring under 9 Newton load? We need to calculate. Okay. So ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಬರೆಯೋಣ. So length of the spring under 4 Newton load, which is equal to A. Alva. So length of the spring under 4 Newton load is A. Similarly, length of the spring under 5 Newton load is equal to B. 5 Newton load is equal to B. Okay. So length of the load under 9 Newton load, which is this length equal to question mark. We need to identify the length of the same spring under 9 Newton load. Okay. So how to calculate this? So let now ಒಂದು ತಗೊಳ್ಳೋಣ. Let original length without load of the spring be equal to L0. Okay, let the original length. Load ಅನ್ನ ಹಾಕಲಿಲ್ಲ ಸ್ಪ್ರಿಂಗ್ ಮೇಲೆ ಅಂದ್ರೆ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಆಫ್ ದ ಸ್ಪ್ರಿಂಗ್ ಬಿ L0 ಅಂತ ತಗೊಳ್ಳೋಣ. ಓಕೆ. ಸೊ ಹುಕ್ಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡೋಣ. ಹುಕ್ಸ್ ಲಾ, ಅಕಾರ್ಡಿಂಗ್ ಟು ಹುಕ್ಸ್ ಲಾ, restoring force in the spring is equal to spring constant into extension. Okay. So restoring force, restoring force developed in the spring, which is equal to spring constant into extension of the spring from its original length. ಆಯ್ತಾ? So ಇದನ್ನ ನಾವು ಈ ರೀತಿನೂ modify ಮಾಡಿ ಬರಿಬಹುದು. So extension can be written as F by K. ಅಲ್ವಾ? So ಇಲ್ಲಿ F ಅಂದ್ರೆ applied force ಆಗಿರುತ್ತೆ. So applied force is equal in magnitude to restoring force ಅಲ್ವಾ? ಸೊ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಇಲ್ಲಿ ಎಫ್ ಆಗುತ್ತೆ. ಆಯ್ತಾ? ಆಮೇಲೆ ಕೆ ಮೀನ್ಸ್ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂಡ್ ಎಕ್ಸ್ ಮೀನ್ಸ್ ಎಕ್ಸ್ಟೆನ್ಷನ್. ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಲೋಡ್ ಸ್ಪ್ರಿಂಗ್ ಗೆಟ್ ಎಕ್ಸ್ಪಾಂಡೆಡ್, ರೈಟ್? ಈ ರೀತಿ ಲೆಂತ್ ಅಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅದನ್ನ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಅಂತ ಕರೆದ್ರೆ ಲೆಟ್ ಎಕ್ಸ್ ಬಿ ದ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಡೆವಲಪ್ಡ್ ಇನ್ ದ ಸ್ಪ್ರಿಂಗ್ ವೆನ್ load is applied. F load is applied. Okay. F force is applied. Okay. So length ಏನಾಯ್ತು ಹಾಗಿದ್ರೆ? ಟೋಟಲ್ ಲೆಂತ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಂತ ಬರಿಬಹುದು ನಾವು? ಸೊ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಪ್ಲಸ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಅಂತ ಬರಿಬಹುದಾ? ಸೊ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಬೈ ಕೆ. ನಾನು ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡಿಗೆ ಹೋಗ್ತೀನಿ. ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು okay, F is equal to K into X implies X is equal to F by K. Take it as equation number 1. Alva. So ivaga total length under load. So load ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಟೋಟಲ್ ಲೆಂತ್ ಏನಾಯ್ತು ಹಾಗಿದ್ರೆ? ಒರಿಜಿನಲ್ ಲೆಂತ್ ಅಥವಾ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ವಿತೌಟ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಲೋಡ್ ಪ್ಲಸ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ obtained in the spring. ಸೊ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡದೇ ಇರುವಾಗ, ಲೋಡ್ ಅನ್ನ ಹಾಕದೇ ಇರುವಾಗ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಎಷ್ಟಿರುತ್ತೆ? L0 ಇರುತ್ತೆ. ಮತ್ತೆ ಲೋಡ್ ಹಾಕಿದಾಗ ಎಕ್ಸ್ಪಾಂಡ್ ಎಷ್ಟಾಗುತ್ತೆ ಅಥವಾ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಎಷ್ಟಾಗುತ್ತೆ? F/K ಆಗುತ್ತೆ. ಸೊ L0 ಪ್ಲಸ್ ಎಕ್ಸ್ ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು L0 ಪ್ಲಸ್ F/K ಆಗುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಟೋಟಲ್ ಲೆಂತ್ ಅಂಡರ್ ಲೋಡ್, ದಿಸ್ ಇಸ್ ದ ಟೋಟಲ್ ಲೆಂತ್ ಅಂಡರ್ ಲೋಡ್. ಓಕೆ, ಸೊ ಇವಾಗ ಒಂದೊಂದಾಗಿ ಬರೆಯೋಣ. ಸೊ ಫಾರ್ 4 ನ್ಯೂಟನ್ ಲೋಡ್, ಸೊ ಕೇಸ್ 1 ಫಾರ್ 4 ನ್ಯೂಟನ್ ಲೋಡ್, ಲೆಂತ್ ಏನಂತ ತಗೊಂಡಿದ್ವಿ? ಜಸ್ಟ್ ಗೋ ಬ್ಯಾಕ್. ಅಂಡರ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ 4 ನ್ಯೂಟನ್ ಲೋಡ್ ಲೆಂತ್ ವಿಲ್ ಬಿ ಎ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ ಅಲ್ವಾ? ಸೊ ಹೇಗೆ ಬರಿಬಹುದು ನಾವು? ಅಂಡ್ ಫಾರ್ 4 ನ್ಯೂಟನ್ ಲೋಡ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು L0 plus force is 4 Newton. 4 Newton divided by spring constant. 4 Newton divided by spring constant. I won't write the unit, just I write the numerical value. Okay, 4 by K ಆಯ್ತು. Second, for 5 Newton load, for 5 Newton load ಏನಾಯ್ತು? B, length is B alva. Under 5 Newton load, we have taken length is equal to B, which is equal to L0 plus 5 by K ಆಯ್ತು. So force is 5 Newton alva. So ಇವಾಗ ಏನನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? Therefore ಏನ್ ಮಾಡೋಣ? B minus A ಮಾಡೋಣ. B minus A ಮಾಡೋಣ, which is equal to L get cancelled, which is equal to B ಅಂದ್ರೆ 5 by K minus 4 by K ಉಳಿತು. Right, 5 by K minus 4 by K, which is equal to 1 by K ಆಯ್ತು, which is equal to 1 by K ಆಯ್ತು. 1 by K ಅಂದ್ರೆ B minus A ಅಂತ ಆಯ್ತು ಅಲ್ವಾ? 1 by K means B minus A ಆಯ್ತು. ಸೊ ನ್ಯಾಚುರಲ್ ಲೆಂತ್ ಅಂದ್ರೆ ಏನು? ಇವಾಗ ನ್ಯಾಚುರಲ್ ಲೆಂತ್ L0 ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್, ಹೇಗೆ ಬರಿಬಹುದು ನಾವು? L0, ಸೊ ವಿ ನೋ ದಟ್ A is equal to L0 plus 4 by K alva, which implies L0 is equal to ಏನಾಯ್ತು? A minus 4 by K ಆಯ್ತು ಅಲ್ವಾ? which is equal to A minus 1 by K ಅಂದ್ರೆ B minus A ಆಯ್ತು. 4 into B minus A, 4 into B minus A ಆಯ್ತು, right? Four into B minus A ಆಯ್ತು, ಕರೆಕ್ಟಾ? 4 into B minus A ಆಯ್ತು. ಸೊ ಇದನ್ನೇ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ which is equal to A minus 4B plus 4A ಅಲ್ವಾ? which is equal to ಎಷ್ಟಾಯ್ತು? which is equal to 5B. 4A plus A ಅಂದ್ರೆ 5A minus 4B ಆಯ್ತು. L0 ಅಂದ್ರೆ so original length 5A minus 4B ಆಯ್ತು, right? L0 is equal to 5A minus 4B ಅಂತ ಆಯ್ತು. So find the length under 9 Newton load. Let us find the length under 9 Newton load. So ಈ ಲೆಂತ್ ಅನ್ನ ಕಂಡುಹಿಡಿಯೋಣ ಆಯ್ತಾ? ಸೊ ಫಾರ್ 9 Newton load ಹೇಗೆ ಬರೆಯೋಣ? ಟೋಟಲ್ total length L is equal to initial length plus F by K. L0 plus F by K. So total length under load ಯಾವ ಫಾರ್ಮುಲಾ ಇದೆ? L0 plus F by K ಇದೆ ಅಲ್ವಾ? ಸೊ L0 plus F by K which is equal to L0 andre 5A minus 4B alva. 5A minus 4B plus F andre 9 Newton alva. 9 Newton 1 by K andre ಏನು 1 by K andre B minus A ಬರುತ್ತೆ. 1 by K means B minus A. 9 divided by 1 by K means B minus A. Right. 1 by K means B minus A. Sorry, it should be into alva. Nine into 1 by K means B minus A. Alva. So which is equal to idana simplify ಮಾಡಿ 5A minus 4B plus 9B minus 9A. So like terms anna add ಅಥವಾ subtract ಮಾಡಿ ಇಲ್ಲಿ accordingly. 5A minus 9A ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು 5A minus 9A ಅಂದ್ರೆ minus 4A minus 4B plus 9B ಅಂದ್ರೆ it is plus 4B. So ಎಷ್ಟಾಯ್ತು ಇವಾಗ it is 5B, right? Okay. Minus 4B plus 9B is 5B, which is equal to 5B minus 4A. Correct? So length under 9 Newton load, which is equal to 5B minus 4A. So what should be the correct answer here? Answer C. Answer C is the correct one here. Answer C is the correct one. Here you can see the correct answer. Option C is the correct answer. Thank you. 5B minus 4A, which is the correct answer. Thank you.